Now we get to the fun stuff, graphs of logarithmic functions. So whenever you want to graph a log function, it's not as easy as just plugging in some random value of x. What you want to do is you want to use values of x in your t-table that should be equal to powers of your base. So what you, or equal to multiples, I should say, I guess. Yeah, powers is better, I guess. Powers of your base. So that means, like, if you have a log base 5, then you would want to use like a log for x. You would want to make this a log of x 25. That's a power of 5. The reason is this is equal to a log, and if this is equal to y, this is equal to a log base 5 of 5 squared, which means that y would just equal 2. So if you're making a table of values to graph, then what you plugged in for x was, this is your x right here, you plugged in a 25, which is a power of your base, and your y value ended up being your exponent, right? 25 is a 5 squared, so your y value ended up being a 2. So what you would do to graph this is you would go to the right, way down here to 25, up 2, put a dot, and there you have that. You'd also try other powers of 5. So say we get y is equal to log base 5 of 5. Well, that's just a 5 to the first. And we know that the log base, so if we put a 5 in for x, we know that this log base 5 and 5 cancel, and you end up just getting a 1. So you go to the right 5, up 1, put a dot. And then you'd plug in a 5 to the 0. Okay, this is 25 is a 5 squared. 5 is a 5 to the first. Well, we need a 5 to the 0 power, which is just 1. And remember, if you plug in a 1 for your x, you'd say y equals log base 5 of 1. That ends up just equaling 0. And unless your graph is shifted one way or the other, your log function should go through the point 1, 0, just like your exponential functions. Remember their inverses, so can't you swap your x's and y's? And that would mean an exponential function would go through 0, 1, and it'd go through 1, 5. Man, so sorry about that one. Oof. Sorry, I was trying to keep it interesting. So that kind of moved around a little bit, but then you could plug in a 5 to the -1. Well, that's just a 1/5. But if you plug that into your equation, you'd say y equals the log base 5 of 5 to the -1, which would just end up being -1. Okay, so you go to the right 5th, down -1, and on and on and on. So your values that go in for the box into your x values should be powers of your base. Base. So let's try example 4 here. In this case, we're going to graph an exponential function and its inverse, the log. So for a, since this is an exponential function, you can just make a table of values because it doesn't matter what they're going to be. And we're going to plug in x's and y's, so make sure you know the difference. Here you can plug in any values you want. Down on the bottom, you're not going to be able to. So if we plug a -2 in, that's going to give us 2 to -2 is a 1/2 squared is a 1/4. So you go back 2, up a 4th. Right about there. Plug in a -1. That gives you a 2 to the -1, or 1/2. So you go back 1, up a half. Plug in a 0, you get a 1. So notice there's our 0, 1, where your graph goes through your y-intercept. Plug in a 1, you get a 2. So over 1, up 2. Over 2, up 4. We graph. And so then we just connect the lines. Going through, going through, going through, going through, going through. Going up. And going to the left. We get those. So then if we graph the inverse of an exponential function, that is your log function, what you're going to want to do is you're going to make a table of values, but we want to use powers of 2. Make this line a little straighter. Ugh. So x and y. So your values of x, you want to plug in values that are powers of 2. Okay? These are going to be powers of 2. So let's plug in 4. Okay, if we plug in a 4 for x, that's the same thing as a 2 squared. So if you evaluate this, log base 2 of 2 squared, that's just 2. So you're going to go to the right 4 of 2. You put that dot. Then you're going to plug in maybe a 2 to the first, which is just 2. And when you evaluate that, log base 2 of 2 is a 1. So you go to the right 2 of 1. And if you notice, look at the table so far, what we've done so far with what we have up top. Your x's and y's should be switching. So if we plug a log base 2 of 1 in here, we get a 0. So that's the inverse of 0, 1. And it's working out on our graph pretty well here. This is a 2, 1, which was the reciprocal, or the inverse of 1, 2. We have a 4, 2, which is the inverse of 2, 4. So my guess is if we plug in a 1/2 here, we would get a -1. And if we plug in a 1/4 here, you would get a -2. And that's what we get. So right here, down here. So what happens is your graph goes down along your y-axis. Wow, little scribbles. And this goes to the right like so. So those graphs reflect over the line of y equals x. And what you can do is you could just make a table for your exponential function and then just flip-flop your x's and y's and you get your values. Notice one thing you need to check with your exponential function, you have a horizontal asymptote at x equals 0. Well, you don't have a horizontal asymptote for your logarithmic function. Instead, what you have is you have a you get a vertical asymptote. So in this case, when you have to start labeling your asymptotes for your for your log function, your graph never crosses this value right here, your y-axis, and it keeps going along there. So they have some similar characteristics, but they also each has an asymptote, and they go through either your x axis or your y axis.